Recording started. So, until now, we have learned about how
Thanks to you.
Behind the scenes.
We're recording, sure.
how to describe motion. So, we learned how to find position of the object, its velocity. Now, question is, which we have not looked into, what causes the motion, why motion actually starts and why motion is changed. For example, to describe when we have object interacting, we need to describe their interaction in some way. To describe how objects interact, we using physics quantity called force. Force is describing how one object acts on another. Force measured in newtons, so unit of measurement of force is 1 newton. And force is a vector quantity, it has direction. So if you want to find, if there are few forces acting on the object, we can find net force or overall force acting. For example, we have force 5 Newton to the right, and we have force acting 3 Newtons to the left. What will be, how we'll find, how we'll find the overall force?
2 newtons to right.
It will be overall, so, and we write it F net. Net force will be equal to 2 newtons, and to say out. So, saying that it's 2 newtons is not enough.
I have a question.
Complete answer, we need to say to the right. Yes?
Do you always like minus the smaller nut? Like how do you, like if 5 was on the other side and 3 was on the other side?
Then the answer
Is it
will be
minus?
5 to the left. Sorry, will be 2 to the left.
So what's F net?
F net is the overall force. When we add all forces, what
Wait,
will
so
be?
it's 5 minus 3.
If we have 5 to the right and we have 3 to the left, overall will be 5 minus 3 will be 2 right. If, as was your question, if it will be 5 to the left, 3 to the right, then overall will be 2 to the left. 2 to the left, yes.
So do you always just like minus the small number?
Yes. For example, we have another example. We have 2 newtons. We have another force 7 newtons. We have force 6 newtons. We have force 3 newtons. And we have 7 newtons up. How we will find the net force in this case? Yes.
Get both like horizontal and vertical.
So we'll first find what will be the net force horizontal. We have what will be total to the right?
9.
It will be 9 and 6 to the left.
So
So overall we have 3 newtons to the right.
And then the other
Now
one.
here
4.
we will have 4 newtons up. How we can find now the total force, overall force? Using Pythagoras. Using Pythagoras. The total will be, if we have 3 newtons to the right, 4 newtons to the up, the total will be this. And the length of this we can find using Pythagoras, F net. This will be F net equal square root of 4 squared plus 3 squared will be equal 5 newtons. At this stage you're not required
Just say the direction.
to identify the angle. It's not required to identify the angle, but we can do it using basic trigonometry. Now, this is a little bit about the forces. Now, this ball now is not moving, it's stationary. Are there any forces acting on it? Yes.
Gravity.
Which force? Yes, there is a gravity acting on
And
it,
your
Air
hand.
resistance. The wind.
And your hand.
and my hand. And because
They're the same.
gravity, force of gravity down, and force of my hand up, they equal and opposite, and they cancel each other. So we got the net force now,
0.
0. If I will remove my hand, then forces will not be balanced. We will have only force acting on it down, and it starts moving. So, what is the reason of object starting moving? Not necessarily gravity. If let's say now I will push it up, it will go up. So, but force. So to change motion, we need to act with the force. And we come into first Newton's law. The first Newton's law states that object retain its velocity if the net force is 0. So, in simple terms, first Newton's law is when net force equals 0, velocity is constant. It's also called often as a law of inertia. Object tends to keep their velocity unchanged. We need to have unbalanced force acting to change the motion. Where you meet this law every day, like in your life, when you are, let's say, on a bus or in the car, and suddenly the driver of the bus press the brakes, what will happen with you? You stay in the bus, driver press brake, you fall forward. Why? Is there any force push you forward? Is there any force push you forward? No. The thing is, the flow of the bus suddenly stopped. Your foot stopped, but your body retains its velocity. So that means it's moving forward because no force acts on it. That's why you're moving forward. Due to inertia, you retain your velocity. That's why you fall forward. If you are in the car, let's say, and car turn left, what happens to you? What do you feel? You like push to the right. Is anything push you to the right? No. You just keep moving straight and car turn left. That's why it's results. And then we come in, for example, to some safety features like seat belt. What are the purpose of the seat belt?
So when the car stops.
To stop you when the crash happens, to move forward and prevent you of hitting the hard dashboard. That is the purpose of the. So we often will be using the first Newton's law like in reverse. So if we have object moving the constant velocity, that means that net force is 0. We can make conclusion net force is 0. And it does not have to be 0 force. It can move and maintain it moves with the constant velocity, does not change. Now, second Newton's law. When we have unbalanced force act on the object, it will start moving with acceleration. And so, second Newton's law tells that, second Newton's law, that acceleration F net divided by mass. So, the bigger the force acting, the more acceleration object will be. The more mass, the less acceleration it will have. If, for example, I will have two objects. One clearly with a bigger mass, another with a smaller mass. If I will apply the same force to the bigger object and to the small object, which one will get more acceleration?
The smaller.
If I will apply same force
The mass is
to
bigger.
the one with the bigger mass or one with the smaller mass, which will get more acceleration?
The smaller.
Smaller mass. So, you see, if I apply some force, with this one, so it does not, same force with this one, it has much bigger acceleration. So, we can make conclusion that if we have big force acting on the small mass, if we will have big force acting on the small mass, we will get big acceleration. If we have small force acting on the big mass, we will get small acceleration. So acceleration depends on the force and the mass. If I will, I push this block with a small mass, it has one acceleration. If I will make bigger mass, put this heavy metal thing on top, I push it, it gets, with the same force, it gets much smaller acceleration. I need to apply much bigger force to push it with the same acceleration as I do it without when it's small mass. So the bigger the mass, the more force you need to give the same acceleration. And usually, when we're solving problems, we will be using it in reverse. We will be using F net equals ma. That's usually how the second Newton's law is written in the textbooks. But the sense of it when we write in this, that acceleration depends on the force and the mass. Acceleration depends on the net force and the mass. And the third Newton's law. Third Newton's law, sometimes it's called action-reaction. So every action has equal and opposite in direction reaction. In more proper terms, if you have two objects, object A and object B, and they interact, and we have force that F A on B, and in the opposite direction we have the force acting F B on A. And the third Newton's law says that those forces are equal in magnitude but opposite in the direction. F A on B equal minus F B on A. What this minus represent? What minus? What the sense of this minus? Opposite directions. When two objects interact, they interact with the same force and magnitude but the opposite directions. So, illustration of the third Newton's law. For example, if I will hit this table with the same force as I will hit it, the table will hit me. So it's a third Newton's law. And by the way, what put it back. So that is
I think I saw one.
now. Question to you: if the action force is gravity pulling you down, action, you sitting on the chair now, And action force is gravity pulling you down. What is the reaction force? Action force is gravity pulling you down. What is the reaction force?
No gravity.
The floor
Oh,
pushing you
the
up.
chair.
The
The chair pushing us up.
It is in between objects.
Everything.
Which object
Us
creates?
standing up. Us
Are we sitting on a chair?
like sitting.
Again,
Us like
which object pull you down? Which object created gravity that pull you
Oh,
down?
the chair stopping us from falling down.
What creates gravity? No, not the gravitation. It's Earth. Earth creates this gravity. So Earth pulling you down. So what should be reaction? Action is Earth pulling you down. What should be reaction?
Keeping us up.
You pulling Earth up with exactly the same force as Earth pulling you down. You pulling Earth up. Why? You easily can see result of the gravity pulling you down. Because when you like jump, gravity immediately brings you down. But you don't see, why you don't see pulling Earth up? Huh? Because it's a third Newton's law as Earth pulling you down, so you means you act on the Earth with the same direction as Earth and you, but pulling it up. Why you don't see any effect on Earth?
Because Earth's mass is so big.
Because mass of the Earth is, I think, something like around 6 times 10 to the power 24 kilograms, I think.
That's not that much.
So you will not see any effect of your force acting on that mass. I'm not exactly remember, but something like that. Now,
All that correct.
another example of the third Newton's law. Zach, you wanted to be in the video? Come here. So, if we can, you know, tug of war when you pulling things, so pull not just too hard, I will not pull hard. So we pulling, I'm pulling this way, pulling that way. So, but as I'm applying the force on this, right, that apply the same force on me. So this force acts on him as he acts on this. So same forces, with the same forces I'm pulling here, he pulling there. So it always should be a draw. Thank you. It always should be a draw because will be the action-reaction forces the same. How then someone can win this competition?
by pulling force.
You're pulling harder, will be bigger reaction force from other side.
What did he say?
Any ideas why actually
He
someone...
get mass.
The
Body
mass
weight. He will bring the mass.
There is a third object involved,
Gravity.
Earth. Because if you do it, let's say, in space, and nobody never win. It always will be a draw. Winning not who harder pulling it, who pushing the Earth harder. Because you push Earth, Earth pulls you back. So winning the team which push Earth. If there will be no Earth involved, third object involved, then nobody never will win this that competition. That will be the another application of the third Newton's law. So that are three Newton's laws that pretty much describe all more. That's why we have the unit of force named after the Newton, and it's 1 Newton. Okay, that's all like theory for today. Like, subscribe, and donate.
Can I go to the bathroom, please?
Are you posting on YouTube?
Please let him carry on.
Are you serious?
Do you
Yeah.
not watch all of his
Do you have a YouTube channel?
Like, subscribe, and donate to help fight help fight terroristic countries and organizations like Russia and Hamas, support Ukraine and Israel.